Hey guys, I want to talk to you guys about abstract classes. Now we've talked about this a bit briefly, but I figured it's been a while and you may not have done this little exercise yet, so let's review. So the point of an abstract class is you've got some classes with a lot of common code. So they have some common code, some different code. In them you will have some methods that are specific to that particular class and some things that are shared amongst everything. You want to be able to use those methods interchangeably. You want a common reference. So the example I used is I was a big Rush Wars fan, and they had a bunch of different types of enemies. But they had different movement type ways, different like AI, different ways of attacking, but they shared like a damage and hitbox and a lot of other generic enemy stuff. So they would be a perfect example for an abstract class. So there's a very high chance that in the background, Supercell made this enemy abstract class, which just had all the common code and had the references for the specific code, and then they had a bunch of subclasses that extended off the abstract class that were specific to each enemy. So let's make an abstract class. It's not very hard to make an abstract class. First, same thing as normal, public, except you're going to write the word abstract class enemy. And what makes it abstract is we're going to have some abstract methods inside, where we don't do the implementation. We just guarantee that anything that extends this class, that is a subclass of this class, must have those methods implemented or be an abstract class itself. All right, so I'm going to make a protected variable. Remember, that means that it can be accessed only by the file itself or its subclasses. So we're going to create a static variable, which remember is a property of the class itself. You've got one variable shared amongst all enemies, anything that extends enemy. So this class and all its subclass all share one variable. It should be private. Starting at 0, but we'll increment it each time we use the constructor, which will be called automatically no matter what subclass you create. So any subclass you create will inadvertently, like in the background at least, if not explicitly, call the constructor for this. So let's do it. We'll make our constructor public enemy. And the point of this is just to set up all the instance variables for it. So we got to set up our HP and our damage and increment our number of enemies by 1. So and we'll increment our static variable to 1. So it keeps track of how many we've created. So we run a normal getter method. Notice that HP is an int, so public int get HP, and just return your HP. And then you run a static getter method for the number of enemies. Same thing, but static in there. And then here's where we get to the abstract methods. That's where the interesting bit is. So these are methods that we haven't implemented in this class, but will in subclasses. We must implement them in subclasses. And we're just doing the method header followed by semicolon. So we'll do public, abstract. We actually don't even really need, yeah, we don't need to put public. By default, it's public. So I'm going to get rid of that. So it's called move, and it takes a Boolean called scene enemy. And that's it. Done. That wasn't very hard. So yeah, we're just guaranteeing that all subclasses have this method. And you know how we had to do the casting for subclasses with a method that wasn't in the superclass? This kind of deals with that. Since the method is declared in this abstract class, which we can use as a reference, we're not going to have to cast it. All right, let's do the next one. Again, we will type in abstract. It's another void method, and it is called take damage. And it takes an int called damage. And then just a semicolon. Not so bad. And again, another method we want to guarantee. Start with abstract. This one's int, and it's called attack, and probably returns how much damage it does. So let's look at our plumber example, which extends this class. It's a subclass of it. So it extends our abstract class. It's got some extra fields which are initialized. In the constructor, it takes the HP and damage and sets those using the superclasses constructor. We're going to need to use the superclasses constructor because there was no default constructor. Remember, there is always a call to the superclasses constructor, whether you write it in or if it's hidden behind the scenes. And then we'll also set the plumber's damage resist. And then it's got its attack method. Being a good Java programmer and putting the override directive there. So it'll warn me if I screwed up my method signature, if there's nothing for it to override, no superclass implementation of it. Anyway, so I didn't really do much here except show you how they might be different. I didn't actually put any code for that, and I don't expect you to either. I've got this little take damage. You only take damage if the damage taken is greater than the damage resist, and then it just takes away the damage taken minus the damage resisted. Yeah, so it does its own thing. It's a melee attacker. It rushes enemies, and it has this damage resist that blocks incoming damage. But for the laser guy, he's a bit different. We're extending our enemy. We need to make a constructor, so it'll be pretty similar. Because of how my grading code works in the background, you can't get too fancy with this. You can't add another variable because it'll assume that it only takes HP and damage. And then the only thing we really need to do here is a call to the superclass. So we could do, it needs HP and damage because we don't have a default constructor. And that's really it. You could try and throw something else in here if you wanted, but because the restrictions, due to the fact that my code is calling something that just takes HP and damage. So you can't add another variable. This is probably great. We got to initialize the necessary methods. How do you know what's necessary? It's all these abstract ones in here. So we need a move, take damage, and attack. And that's really all we need. So we can do that any way we want. We can do public, void move, and I think that took a Boolean called seen enemy. By the way, it doesn't really matter what you call it. If I'm going to be a good programmer, I should probably throw in the @override. Not strictly necessary, but a good idea. It'll give me an error that tells me if I screwed up the method signature. But it looks good. I should be fine. And so I'll be super boring. Just say he gets in range. And then I also have to implement a take damage and attack. And what do I need for take damage? I need a damage. All right, again, it's a good idea to throw in the @override to make sure we're doing this right, and then do whatever the heck you want in there. I'll leave it blank for now. You should do something so you know it works. And we got one last one. We got to do attack, which is an int one. That doesn't take any parameters, and let's just say you shot your laser at the guy. And if you remember Rush Wars, the laser could go through multiple enemies, so it was a great attack. And would have to return an int. Let's say the laser does 10 damage. Anyway, so I can do things now that I've got this enemy abstract class. I can make a, let's make an enemy array. And we'll throw in 4 of them. And I'll just do a little mix of laser guys and plumbers. So I can say enemies 0. Let's make it a plumber. And that's, let's say this particular plumber has 5 HP, does 10 damage, and has a damage resist of 2. Now let's make the next guy a laser guy, just for fun. And this guy, they're a little beefier. They have 20 HP. They again do 10 damage, and they have no damage resist or anything like that. And then we can make this guy a plumber. And let's say he's a little beefier. Not that they actually are in the game. Well, you can make them that way. And we'll say this guy is a little beefier as well. All right, so now that we've got our array set up, we've got a common enemy reference. Now we can cycle through the array and just use their common methods with polymorphism. So we could be like, for enemy, using the fancy for loop method, the enhanced for loop. So for every enemy and enemies, let's make them use their, what's a decent attack? Let's use their move attack and their attack. Use their move and attack. And we'll say they've seen the enemy. So for every enemy, have them move as if they've seen the enemy and get them to attack. Yeah. And let's try running this thing. We can compile and run it, and hopefully there's not, oh, I screwed up the compiling somewhere. Laser guy, I forgot a semicolon. Silly me. All right, let's try this again. There we go. Now if we run it, so you notice the first guy, he rushed the enemy. That's his move thing, what he does when he does move for a plumber. And then he hits the enemy with a pipe if in range and do 10 damage. And then the next guy was a laser guy, so he gets in range for the laser, and then he shoots the laser at the enemy. And then our next enemy was a plumber, so he again hits the enemy with a pipe if in range and do 12 damage because he was the beefier plumber. He rushed them and then hit him. That's the move and attack. And then the last guy got in range for the laser and shot the lasered enemy. So polymorphism in action. We've got a common reference that works for all enemies. And even though they've got wildly different implementations, we can just cycle through. So this sort of code is really common in games. Sort of every moment, there's usually an update method that will vary depending on the object. But if it's got a common reference like this, that's helpful. So you just have it update, say, through all the enemies and do their update or whatever method you need to do. So it updates its state and attacks and moves and does whatever it's supposed to do. Anyway, this video is way too long. Sorry about that. If you made it this far, thanks for listening.